This question is from GATE 2014 Mechanical Engineering paper set 2, question number 30. The flexural rigidity EI of a cantilever beam is assumed to be constant over the length of the beam shown in the figure. If a load P and bending moment PL by 2 are applied at the free end of the beam, then the value of the slope at the free end is. Let's see how this will be solved. There is a concentrated load P at the free end and a moment that will be constant throughout. So the bending moment diagram will be a simple rectangle along with a triangle attached. So it will be a trapezium. And we can find out the area of this bending moment diagram, and we can use the moment area method to calculate the slope. Now in the moment area method, slope is calculated by taking the difference between slopes of 2 points. So one point that we'll choose will be the fixed end, while the another will be the free end where we need to find the slope. Because when we plot the deflection curve, this is a fixed end, slope here will be 0. This is the end condition here, and the beam will deflect like this. So we have here the slope is 0. If we mark this point as A, then slope at A is 0, and we need to find out slope at B, which will be shown like this with respect to the horizontal. What is the angle made by the deflected curve of the beam? So theta B, of course this is non-zero, and we can find out theta B by finding out the area between point A and B on the M by EI diagram. Let's construct the M by EI diagram here. If we project it over here, a constant moment is applied. So this moment is PL by 2. Moment formed due to this point load P can be represented as this inclined line, giving the moment here at free end to be P into L, PL, and then gradually decreasing becomes 0 at the free end. So this is bending moment diagram. We can draw M by EI diagram over it if we just divide each of the ordinates of this diagram by EI. So at this end we have PL by 2 plus PL, that is 3PL by 2. So this ordinate will be 3PL by 2 EI. Although we are taking these ordinates to be same as on the bending moment diagram, but 3PL by 2 EI will be of course smaller than 3PL by 2 because we are dividing with EI. So we assume that M by EI diagram is drawn over the BMD only with the ordinates being changed. But these ordinates will of course be very small, and this diagram will be scaled for constructing the M by EI diagram, while this ordinate is PL by 2 EI. So this is the M by EI diagram. Now using the moment area theorem, the first moment area theorem, we have theta B minus theta A will be equal to area on M by EI diagram. Of course, only between the points A and B. So we have theta B is non-zero, theta A is 0, and theta B is what we have to find is equal to area of this diagram will be area of this trapezium. It will be 1 by 2 into the base is L. This base is L, length of the beam. So we have into L into addition of these two ordinates. So we have 3 by 2 plus 1 by 2 into PL by EI. This gives us 4 by 2 in the bracket, which is 2, and 2 by 2 is 1. So it is PL square by EI. Theta B at free end is PL square by EI. Let's go back and mark the correct option. So the correct answer is in option B, where the value of slope at free end is given as PL square by EI. For further reference, you can refer the NPTEL video lecture 32 Deflection of Beams 3 from the course lecture series on Strength of Materials by Professor S.K. Bhattacharya. He is from Department of Civil Engineering, IIT Kharagpur. I hope the solution will help you clear your doubt. Thank you.